So, this is the next question on the menu today. What is the step? What are the steps for simplifying radicals? That's rad, bro. What is a radical in the first place? Radical, I mean, some people say, that's radical, meaning that it's, super out there or super cool. In math, radicals are roots. Some of them look like this. We got like, something, maybe x. That's a square root. And maybe we have something like this. So it could be like that. That's a cube root. And, well, we might not have just 2 or 3. By the way, if you don't see anything there, it's a 2. Just know that it's a 2, because square root is probably the most common radical that you'll see, but it is possible that you'll see other roots, or radicals with other numbers here. That just specifies, like, the root. If you got n, that could be any number that you choose, any real number that you choose. That would be an nth root. Like if n was equal to 5, you'd say the 5th root of x. That's essentially what it's meaning. Okay, now what you can do is that roots are essentially exponents with fractions. So the square root is equal to x to the power of 1/2. The cube root is equal to x to the power of 1 divided by 3, 1/3. The nth root, well, that will be x to the power of 1 over n. And n, like, let's say, let's say, for example, we had n equals 5 here, the 5th root. It would be x to the power of 1 over 5, or x to the power of 0.2, whichever suits your fancy. Okay, that's a great way to start simplifying radicals. Another thing that you can do if you have a radical is, if you have things inside the radical that are raised to the same power as like the thing that's on the outside of the radical, you can move them out. So let's say we have a situation like this. You can also definitely factor out the things inside. This will typically be a helpful thing. Let's say we got like the square root of 18. We know that 18 is equal to 2 times 9. Hey, what do we know about 9? That looks like a square type number to you. Looks like a square type number to me. We should see that this is just 2 times 3 squared. 3 times 3, is that 9? Sounds about right. Studied my times tables for many times on many tables. Okay, now you see how this radical is the square root. Like, there's an invisible number here, but that, like, we can see the 2 there. It should be there, but we don't need to write it because mathematicians are lazy. So we can look inside. Hey, is anything inside of there squared? Oh, there's a 3 squared in there. That means we can pull it out and remove the square. And this is equal to 3 times the root 2. It's basically moving it out here and remove square. Okay, now of course if this was like a 3rd root or an nth root, we would do something different. Like, instead of, we'd be looking for cubes inside. So maybe an example of that is like, I'm trying to think of a nice cubey number. 54. According to my calculations, 54 is, let's say that's the cube root. According to my calculations, 54 divided by 2 times 27. That's 54. Yep, sounds about right. So the cube root of 2 times 57. Nope, not 57. 27. My apologies. The 2 and the 5 do have some similarities in their appearance, so please forgive that. Now, is anything inside of there cubed? 27 seems like a cubey number. So what's 3 times 3? 9. 9 times 3? 27. Whoa! It's almost as if 27 is 3 to the power of 3. So it's like 2 times 3 to the power of 3. Now we can bring this outside the radical, and we can remove the cubed power as we move it out, because we're doing the cube root, we're looking for things that have cubes underneath the root, and we're going to move them out there. So as the 3 moves out, it loses the power of 3 because of the cube root. And hey, would you look at that? We just get 3 times the cube root of 2. And that would be our final answer. And you send that through your calculator, I'm sure you'll find that this looks good. Cool. Now that's typically what radicals are. When you get into calculus, you'll see that converting them into fractions instead of keep them as roots could be a useful move to do. But yeah, let's actually see what their examples are. Okay, so the example that they have here under the root is 9 times a to the power of 4 times b squared times z to the power of 6. Hey, they recognize all of those are a little bit squarey. Like they're all something squared, right? 9 is 3 squared, and obviously the variables with their exponents, there's something squared. So they wrote them as a square, and then moved all of them outside of the root. Underneath the root, it's just 1 left after you factor out everything else. The square root of 1 is 1. They don't really need to write that, so they can just leave it as is, as 3 times the square root of a to the power of 4, so that's a squared. B, it loses that power of 2, and z, it to the power of 6 becomes to the power of 3, because the square root of to the power of 6 is to the power of 3. So that's another thing with like exponential rules. Multiplication is kind of how it works. Also, if you converted the square root into a power, and then you did all of those to the power of 1/2, like it's just multiplication, and you would see that it all works out good. Okay, so the above solution is correct, and that's a good time. Solution is correct. Spooky. It'd be very spooky on Halloween if it was not correct. Happy Halloween!